All right, now we're ready. All right, so what did you say? X is what? X is greater than 1. X is greater than 1. For the inequalities, you have to remember that there's a way of writing your solutions known as interval notation. Okay? Interval notation. It has to do with the number line. All right? If you want your solutions in interval notation, if your answer was X is greater than 1, on the number line it'd be 1 with an open circle and an arrow to the right. Okay? That's a little high schoolish. So when you get to calculus in this class, you write it in interval notation. An open circle is used as a parenthesis. And since this is going from 1 to the left, you put a 1 there, and any left-hand arrow is known as infinity. And you close it up. Okay? That would be the exact same solution. That's how you write your answer. So for instance, if you had, I don't know, let's say you had 7 less than or equal to x less than 10. Okay? On the number line, we're just talking about how to write your solutions when you find the answers to the inequalities. Because a lot of kids have a problem with this, first time they've seen it. So if it's 7 to 10, if you have a closed circle and an open circle, you'd write your answer in interval notation using a bracket, a 7, a comma, 10, and a parentheses. It has a lot to do with computer science. I know, I had to take a lot of computer science courses to be a math teacher. Don't ask me why. So we got any right-hand arrow is going to be a negative infinity. Any right-hand arrow is going to be a positive infinity. Any open circle gets a parenthesis. It could be left or it could be a right. And any closed circle gets a bracket. It could be a left or it could be a right. But anyway, that's how you transfer your answers from a number line to the interval to write an interval notation. Okay? And everybody knows how to make a good infinity symbol, right? No, it ain't no sideways 8. It should look like a Pringles potato chip you'd like to eat. That is how you qualify a good infinity symbol versus a bad infinity symbol. Okay, this is good. This is bad. Take a little time, a little care, a little effort, and it goes a long way. Okay? That won't cut it. The little Zorro's, infinity sign. Done. So anyway, you got the idea with what the symbols mean. No, I wasn't going to sit here and talk about what they mean. I was going to talk about how they transfer to interval notation. In your textbook is a very interesting chart. It has it all broken down. I'm going to tell you the best way for you to remember it is that open parentheses means open circles. Brackets mean closed on a number line. That's your style of thinking. This would be a bracket and an open, and a bracket, and open all the way out to infinity. That one's not very good. Okay, but you get the idea of how it works. And this one, closed, out to infinity, so on and so forth.
Why do we write like that?
Infinity?
No, just like brackets and...
Oh, it has to do with computer science. It's how you put in a line of code a solution. And also calculus does a lot with intervals. So this is too messy to work with when you have a lot going on. Here's my question to you. Actually, it's to you. Let's say I'm up here in this one right here. Okay? Let's say I have this shaded region plus I have this answer C to D. Open, closed, everything in between. How do you represent not one, but two regions for your solution? You'd have the closed A to B. And how do you add the open C to the closed D? How do you add that? Yep, and there's one more thing needed. Close Close. The U. The union, the joining of two sets, the joining of two elements. Union, the joining of. Okay? Did you get that? You got that. If I walk over right now, you got that. Then get that because you're going to need that. The U. It's a U. The union, the joining of two things. All right. So we know how to do one region. We know how to do two regions. And we're ready to do interval notation. And some of you that are factoring not set equal to 0, you're losing your answers. That's important when you're talking about inequalities. Okay? I had one kid had a 4th degree polynomial in the homework and came down to one answer. Like, where are the other 3? They're irrelevant. No, they're not. They're important. So anyway, you got to be careful about when you get rid of things. Hopefully they'll come up here. So let's get started. Express the inequalities interval and sketch the graph. Well, what's that going to be, an interval? Question 4. What kind of interval is that?
A good one.
Yeah. 3 to 7. Close, close. Yeah, so it's going to be a bracket 3 to 7, close. All right. Hey, if you can get that right, and we do, those questions, you can get it right. I thought the last question on the quiz was easy. Express it as single terms. It didn't go so well. All right. What's infinity mean? What kind of arrow? Left or right? Yeah, it means a right-hand arrow. From -3 to infinity. And this parenthesis means open circle. So you kind of get an idea how it looks. Okay? If you had an open circle with an arrow, all you do is take that and put it on the number line. So you have this with a 3. And that's your graph. Okay? Interval notation. The last textbook we used just kind of touched on a little bit, but this one actually dives into it in the first chapter, using it throughout. Yeah, -3, right, thanks. Okay? Fantastic. Moving on. No sense in standing still. This one. You should always try to get things equal to 0 and don't be slashing variables, getting rid of them. On this case, it's pretty easy. How many answers are there going to be? 1. Well, there's sort of 1. Just get things on the same side. Subtract the x, subtract the x, subtract the 3, and subtract the 3. -11 is greater than 4x. Does that look right? Sure. So you can write this as x is less than -11 fourths. The other way you can write it is how? Yeah, x is less than -11 fourths. There's a couple ways of writing that answer like that, but there's only one way to write it in interval notation. The reason I put that up there about the variable and looking at it, some people always have to have the variable on the left to do this. Others, well, they don't need the variable on the left. Anyway, -11 fourths. Open circle because this was a greater than sign, but it had a little equal sign with it, so that makes it a circle. And the arrow is going to go to the left. Okay. Does anybody ever get confused about which way the arrow goes? Have you ever heard of test points? Have you guys heard of test points? Never heard of test points. All right. A test point is name a number on the right side of -11 fourths, your favorite number. I would pick 0. Some people pick 1. Then you put it into this equation. Is -11 fourths bigger than 1? The answer is no. So you know the arrow goes the other way. Okay? I use test points all the time whenever I'm doing inequalities, especially when it comes to factoring. Yeah. You can do a lot. You ready to try another one? I am too. Oh, this one. How many people in the room would simply multiply this over and be done with it and say anything, everything? Yeah. Some people in the room have forgotten this, and that costs them a point. That means x cannot be negative 5 halves. Why can't x be negative 5 halves? Can't divide by 0. So on your number line, guess what you put? X cannot be negative 5 halves with an open circle. That means it can't be negative 5 halves. Is there anything else x can't be? No, I think we're good. Now, do you remember what a quotient is? Good. The top number is always going to be positive, isn't it? Top number is always positive. When is the bottom number? Like, what's the test point on the right side of negative 5 halves? Give me an example of a test point. 0. So my test point is going to be 0. If I put 0 into the numerator, it doesn't change, does it? It's still positive. If I put 0 in the denominator, is it positive or negative? Positive. What is a positive number divided by a positive number? Positive. So it's a positive region of quotients. All right? What's the number to the left of negative 5 halves? Negative 10 billion. I like that. Negative 5. I like that. If you put negative 5 in for your test point, if you put it in the top, it's still going to be positive. What happens if you put it in the bottom? Is it going to be positive or negative? Negative. So what is a positive number divided by a negative number always going to be? Negative. So it's the negative region. Now you have to ask yourself, is the question asking for a positive or negative region? It's asking for the negative region. How do you know it's asking for the negative region? Well, because it says less than 0. That means a negative number. We talked about that. A less than 0 is negative. There's a question like that on your test. I think it's number 25. I needed one more to make an even 25, so I picked something like this. Something really easy. So the answer is going to be everything from negative 5 halves this way. So how do you write that as an interval? Yeah, parentheses, negative infinity, negative 5 halves, and close it off. There's only one way to write that answer. If you use an inequality sign, there's lots of ways of writing that answer. Don't you agree? I agree also. Yep.
Why isn't infinity for the negative 5?
Oh, because on the number line, negative 5 halves will be right here. And the left-hand arrow is over here. So this always goes from left to right, just like on a number line. Since I see the negative infinity right here, I go in order from left to right. Okay? Fantastic. I can ready to try another one, don't you? All right. Oh, we talked about this. These are the two. You see right here? The absolute value of A is less than B means negative B less than A less than positive B. And that's an and statement, isn't it? That's an and. This one right here, the absolute value of A is greater than B, is an or statement. It means A less than negative B or A greater than B. We talked about that as well. I love those absolute values. It's just nifty. So, there they are again. All right. Now, before we solve it, you have to get rid of all the grouping symbols. So I get rid of the absolute values. Which one is this? Is this going to be 1 or 2? Rewriting using number 1 or rewriting number 2? Number 1. So rewrite it using number 1. Nice. Negative 0.03 is less than x minus 4. Oh, sorry, equal to 0.03. Fantastic. And how do you solve that? Yeah! You have to add 4 to all 3 of them. This is an epsilon delta statement and a proof. 0.03 is delta. You'll get to those later. So it's not too bad. 3.97. Is that right? And you just use the brackets, don't you? Sounds good. Fantastic. I'd say that's pretty good. You getting all right with the brackets and the parentheses? Did you have those last year? Okay. So it's not too difficult to see what it means. The only hard thing about the brackets and the parentheses is when you put your answers in terms of graphs. You all right? Yep. Good. We're moving on. Oh, this is a good point. The last statement we had, this is when the A was isolated. There was nothing else next to it. The A is isolated. So before you rewrite it, you have to isolate this. You have to isolate it first. That means get it by itself. So you're going to have to get rid of the 2, and you're going to have to get rid of the negative 2. Do you guys like the comments I write on your papers, or rather I just mark them wrong and move on? You like comments? I feel like an English teacher sometimes, though. Sometimes I write like 5 or 6 steps. That's okay, as long as it helps. I figure it helps to the big time when the test gets here, right? All right. So you have to isolate this first. So that means, what are you going to do? Add first or divide? Why don't you divide first? Well, you could. You have to divide every term by 2, don't you? Well, we'll add first. But you could divide everything by 2 and, then whatever. And then divide, right? No, but don't forget, I'm going to change something. I hate a negative variable in an absolute value sign with an inequality. I hate that. Does anybody know why I would hate that? Anybody know why? How many times do you actually remember to flip the sign when you divide by a negative? Every time? I got the test scores that say otherwise. I've seen, I would say hundreds of students forget that. So I would look at it as 7x plus 11 is greater than 6. Do you remember I mentioned epsilon delta proof? This is a big thing in an epsilon delta proof is you want that coefficient to be positive. That's another reason I do it. I know we're not doing epsilon delta proofs, but that's another reason why I want that positive. Because we said that's the same thing. They're equal, right? Okay, you got to get familiar with the absolute value. Now I'm ready to bust this out. Is this rewriting it using number 1 or using number 2? Sam, what do you think? Nice. Is that an and or an or statement? It is an or. Is that what you said? Excellent. So we got the 7x plus 11 greater than 6. Got the or 7x plus 11 less than negative 6. Okay? Remember every single time. I like that. Well, I think we're ready now, don't you? 7x is less than negative 17, or 7x is greater than negative 5. X is less than negative 17 sevenths, or x is greater than... Is everybody else getting this? X is greater than negative 5 sevenths? Do you want to go to the number line or straight to the interval notation? Number line? I say number line. Notice I didn't ask how many don't care. Negative 17 sevenths. Negative 5 sevenths. Less than means open circle and arrow to the left, right? And negative 5/7 means open and arrow to the right. Now you got to write this in interval notation. All right. Left-hand arrow means what? Negative infinity. All the way to negative 17/7. Bracket or parentheses? Perfect. Union. Aha, there's that union. The joining of two sets. Both these regions are what you want. You want region 1 and region 2 in your answer. So, union, negative 5/7 to infinity. Pretty good? Piece cake. No questions. We haven't even got to the fun part yet. Factor. Hopefully we'll get to that. I know. It's exciting. No. Uh-oh. The absolute value of a number is between 1 and 5. Have you ever seen an absolute value with a double inequality symbol before? Why would the word rewrite be up there twice? Well, how do you do that? How do you rewrite it twice? I'm not going to tell you. Chase is. What? Well, you got both properties at once here. You got property number 1 right here. Oh, sorry, number 1 right here. And you got property number 2 right here. So you have to work this problem out. Then you have to work this problem out. Then you have to put them together. That's exciting. No, it doesn't. The only thing to make this problem better is if it was your birthday today. And you can solve this problem out as if it was your birthday. Your birthday? 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 Nice, we got one. Steve, mathematically speaking, you always find a birthday in the room. Happy birthday? What, he just said yes? See, that makes the problem a lot better now. Go ahead. I'll help you out a little bit, okay? And then this one becomes this. Nice. I can always find the birthday. So how do you write 1 is less than the absolute value? Is that using 1 or 2? Okay. 2. Now you're excited. I understand your birthday. All right, so how do you rewrite that? Okay, x is less than negative 1 or? Good. And this one? Right. I think so. See, it looks like such an easy problem. There's so many little twists on this problem. All right. X is less than negative 1. Arrow to the left. Got it. And we got a 1 right here, open, and an arrow going that way. Perfect. And then we got to put in the negative 5 to 5 situation. Negative 5 to 5. Are those open or closed? Open. And this goes all the way down to here. So what the heck will be your answer? You think any number you can put in here will actually work? 10 billion is a real number. That doesn't work. Right. It's going to have to be the regions that they have in common. Why? Because my question is, how do you read this? Go ahead. I'll let the birthday boy off the hook. Go ahead. He just said it. He said 1 is less than the absolute value of x, and he said the word and. The absolute value of x is less than 5. That means the word and means what do they have in common? They have open circle here in common. It's an and. It's how you read it naturally. So the answer to the question is -5 to -1 union 1 to 5. That works. So if you just read it, understand what the words mean, makes that problem a lot easier. Okay? I like that. I need a factoring one. Like a factoring with a numerator and a denominator. Just factor. Darn it. Okay. Whenever you factor with an inequality, you have to understand what region you're looking for. This is less than 0. So what region is that? You're looking for the negative region on your number line. How do you get the numbers on your number line? You look at the factors. So you find the factors and you look at them. Okay? Perfect. What are the factors? What are the solutions for the factors we have up there right now? -2. And we got 1. And we got 4. All right. Can x equal those numbers? Yes or no? It can, because it has an equal sign. So close dot, close dot, close dot. Now I do test points. If I pick a number like -10 billion, the first factor, will that be positive or negative? If I put -10 billion in for that, it'll be negative, right? And this second factor will be what? A negative. And the third factor will be what? Positive. So if I multiply all three factors together, this entire region would turn out to be a positive region, wouldn't it? Is that what I want in my solution? No, it's not. I want the negative region. Pick a number between -2 and 1. 0 is a good guess. If I put 0 into the first factor, it comes out to be a positive factor. If I put 0 in right here, it comes out to be a negative. And 0 right here turns out to be a positive. If I multiply all three factors together, it'll turn out to be what kind of region? A negative region. I want that in my answer, don't I? And that region goes from -2 all the way to 1. -2 to 1. That's the region I want. Am I done? No, I got 2 more regions to check. You've already taken out all the zeros. Any closed dot's going to be a 0. So the only thing left, a number to be, if it can't be 0, is positive or negative. That's the only thing that's left. It's kind of like that pigeonhole principle we talked about. Hold or hold? What did we say? Hold. All right. 3 is a good test point. 2 is a good test point. 2.5. 3.9. Any of those numbers will work. If I pick 2, that'd be a positive, and a negative region. Yeah. So the whole region is negative. Don't want that. Wait a minute. Is that right? 2. Positive, positive, positive. Yeah. Wait a minute. Positive. So that's a positive region. Ooh, that was close. And finally a 10. A positive, and a negative. So that's a negative region. Oh, is that what I'm looking for? Nice. 4 to infinity. And how do I join 2 intervals together? A union of the 2. Nicely done. I don't know how much farther we got. Oh, nice. And, ooh, look at that. All right, anyway. We'll probably stop there. Oh, that's going to be a good one. 36 is going to be a great one. I know. Better say there's someplace to start. So we'll start with 36 tomorrow. And let's see. Let's go back. So we're on page, what page are we on? 107? 85. So we're going to do 1 through 29 odd. Fantastic. All right. Hey, you got time to get started actually today, don't you? All right. Let's go ahead and get started.